Hello students, how are you doing? How was the week? Now we continue with the course on geometry because we've earlier discussed about power transmissions. Now we know we can transmit power from one shaft onto one pulley by gear, belt, chain and clutch. But now we're taking the very first aspect of it, which is geometry. Relax as you enjoy the class. Objectives are to identify different types of geometry, to calculate the velocity ratio for simple and compact geometry, and to calculate the velocity ratio for epicyclic train by tabular form. Introduction. Sometimes two or more gears are made to match with each other to transmit power from one shaft to the other. Such a combination is called gear train. The nature of the train used depends upon the velocity ratio required and the position of the axis of the shaft. Gears are commonly used to achieve large speed reduction. Types of gear train: we have the simple gear train, the compound gear train, the bracket gear train, and the epicyclic gear train. In the simple gear train, as you can see, you have the driver, and as well the follower or the driven. Now the driver here is rotating in a clockwise manner. As you ride, the driver will follow it in an anti-clockwise manner. As you can see, power is being transferred from one to the other. Now, our major concern is the speed ratio, which you can see that N1 all over N2 is equals to T2 all over T1. This shows the speed ratio. This is a special type of simple gear train. In this case, we have the intermediate gear in the middle. This really have no effect on the speed ratio because it's between the driver and the follower, which you can still see the formula is still N1 all over N3 is equals to T3 all over T1. Now we have the compound gear train, where there are two or one gear on a shaft as shown below. It is called a compound train of gear. As you can see that on this shaft, which has pulley 2 and 3, just a single shaft is having 2 and 3 on top. That is a compound gear train. And the speed ratio is still N1 all over N6 is equals to T2 all over T1 times T4 all over T3 times T6 all over T5. That gives us the formula which says that speed ratio is equals to the speed of the first driver all over speed of the last driven or follower, which is equals to the product of the number of teeth of the drivens all over the product of the number of teeth of the drivers. Now we have the reverted gear train, when the axis of the first gear, the first driver, and the last gear, last driven or follower are coaxial. Then the gear train is known as reverted gear train as shown below. As you can see that 1 and 4, 1 is the driver while 4 is the follower. They are coaxial, and the speed ratio is still N1 all over T4 is equals to T2 all over T1 times T4 all over T3. Now we have the epicyclic gear train. The epicyclic gear train are useful for transmitting high velocity ratio with gears of moderate size in a comparative lesser space. As you can see, this is an example of an epicyclic train as shown in the diagram. You have the gear A and the gear B, and you have an arm about which gear A and B will rotate. Now we have the tabular method. T is the number of teeth of gear A and T is the number of teeth of gear B. As you can see that a table is used to solve an epicyclic gear train using this diagram. Now you draw your table, which you have the first step is the arm is fixed. You always fix the arm. The arm is fixed, and then A is given plus 1 revolution in an anti-clockwise manner. So this because the arm is fixed, the arm will be 0. Then A is the one rotating, you have plus 1. As a result of A rotating B, using your speed ratio of N2 all over N1 is equals to T1 all over T2. So as a result of this, you now have minus TA all over. The reason for this minus is because since A is going in anti-clockwise manner, then B will be going in clockwise manner. Then you now give A plus S revolution. So just multiply what you have on the top of table 1, multiply everything by x. 0 times x is still 0, plus 1 times x you have plus x, and minus t all over b times x you have minus x t a all over t. Then you give each member plus 1 revolution, the arm plus 1 revolution when it's rotating, and A as well plus 1 revolution, and B as well plus 1 revolution. Now what you now do is that you now find the total moment, adding what is on column 2 and 3. You add them together, that will give us plus y, 0 plus y plus y, x plus y, you have x plus y, y, when you have minus xt all over tb plus y, you have y minus xta all over tb. Now this is a question for us to solve. In an epicyclic geometry, an arm carries two gears A and B, having 36 and 45 teeth respectively. If the arm rotates at 150 revolution per minute in an anti-clockwise direction about the center of gear A, which is fixed, determine the speed of gear B if the gear A, instead of being fixed, makes 300 revolution per minute in an anti-clockwise direction. What would be the speed of gear B? Now we're given that the speed of the arm, which is NC, is 150 revolution per minute anti-clockwise, TA is 36 and TB is 45. Now using our tabular method, we know the arm will be fixed, that will be 0, and if we give A plus 1 revolution in the anti-clockwise direction, we have plus 1, while B, which is going in the clockwise manner, that will be minus T over TB, using our speed ratio for formula. Then give A plus S revolution, multiply everything in column 1 by x, you have 0 times x, x, 1 times x plus x, and minus t over tb times x minus x tb over y, and give each member plus y revolution, which you have there. Then you had everything that is in column 2 and column 3, 0 plus y, x plus y, x plus y, and minus xt over tb plus y, you have y minus xta all over tb. The speed of JB when JA is fixed. Say the speed of the arm is 150 revolution per minute anti-clockwise. Therefore, from the fourth rule of the table, we know that our y will be plus 150 revolution per minute. Also, the GRA is fixed, and therefore x plus y equals to 0. So x will give us minus y will give us minus 150 revolution per minute. And the speed of JB from our table, we know that MB is y minus x times t over tb. Now, substituting all the values, we now have that the speed of B when GRA is fixed is 270 revolution per minute anti-clockwise. The speed of JB when A makes 300 revolution per minute clockwise. Since JA makes 300 revolution per minute clockwise, therefore from the fourth rule of the table, we know that our x plus y is minus 300, so x will be minus 300 minus y, and x equals minus 300 minus 150, so x will give us minus 450 revolution per minute. Now to find the speed of JB, we use our formula, which is MB equals y minus xt over tb. If you substitute value, you find out that your MB is 510 revolution per minute anti-clockwise. In this lesson, we have learned the different types of geometry, how to calculate the velocity ratio for simple and compact geometry, and how to calculate the velocity ratio for epicyclic geometry by tabular form. See you in the next class, students, and have a good day.